Welcome, Rational Functions 3. This is the last video in this series on rational functions. So we did in the past two videos cases where the top degree was less than the bottom. There were two examples where the degree was different by one, less on top, more bottom. There was an example in the past where we did the same degree, equal degree, polynomials of equal degree on top and bottom, and this is the case where the third possibility, there is no other options, that you have more on top than the bottom. So that means the degree on top is greater than the degree in the denominator part. So look at this example right here. We have quadratic divided by linear. So first case is to tackle the domain. Okay, so our domain, let's find out. What do? You have to set the denominator equal to 0 and solve it. So this is why you have x is real except for -1/2. So no matter what you do, your graph is not defined when x is -1/2, period. This is the example that is very similar to the previous one. This is why you can see that when you factor the numerator, you have two factors, 2x plus 1 and x minus 3. And also you have now common factors, 2x plus 1, that you will simplify the expression. So this is why you get f of x is equal to x minus 3. If you remember, this is a line. This is an equation of a line, and we know that the slope is positive here. And then the question is, so I have a restriction. Yes, we do have a restriction. So does that mean that my line is supposed to be interrupted? Yes, this line is not a continuous function because of the restricted value in the domain. So as you graph that, you will see that there is a point of discontinuity at -1/2. So let's go and graph it. My line is supposed to be somewhere here. Okay, so the x-intercept is 3, y-intercept is -3, and there is a point of discontinuity. Why is that? Because the restriction in the domain. And the range values now, since this is a straight line, you would say, well, everything would work, but the actual values for the range set are real numbers. So y is element of R such that y is not equal. And what is the value that has to be excluded? So you have to find out by using the restricted value for the domain. So you will find how much is f when x is equal to -1/2, and you use the simplified version this time. So this is -1/2 minus 3. So this is -7/2, if I did it right. -3, so 6 divided by 2, minus 1/2, so 7/2. So this is the domain with one restriction, and range also with one restriction already. So now we'll move to another example where the top degree is greater than the bottom, and we'll discuss different possibility in that scenario. Before we move there, let's look at the asymptotes cases here. So we have no vertical asymptote, no horizontal asymptote. Self-explanatory case, it's a straight line, so the graph is just a very simple graph that we have learned about it in the previous math courses. So let's move on, shall we? Okay, so very similar question. Second degree on top, linear bottom. The domain quickly is figured out by finding the solution to the equation. Let 2x minus 1 be 0, so x shall not be equal to 1/2. So there is a potential of 1 vertical asymptote. Usually that's the way that you should be thinking. Restricted value means possible vertical asymptote, or something else. Something else meaning the donut hole, the point of discontinuity. Since you can factor the top part of this equation, right, into these two binomial, you can see that there's no way that we can simplify this expression. So there's no way that I can divide anything by 2x minus 1 from top. Since we cannot do this, we cannot make this equation simpler. So what we're going to do now is to divide the entire numerator by the denominator. So this is the 2x minus 5x minus 3 divided by 2x minus 1. So in the process, you get the result that this is equivalent to x minus 2, and the remainder is negative 6. So you may wish to say now that this equation has the following format. So the new equation now looks like this one here, highlighted in green. X minus 2 minus this remainder, 6 divided by 2x minus 1. So x minus 2 suggests that this will be a line as x is increasing to very, very large values, or x is decreasing to very, very small numbers. So this is what is shown right here. As x is approaching to positive or negative infinity, f of x will be approaching to x minus 2. So this indicates that there is a slant asymptote here. So this graph has no horizontal asymptote, but it has slant asymptote, also called oblique asymptote. So remember, when the degree of the numerator is greater than of the denominator, and the difference is 1, the difference in degree is 1, so there is no horizontal asymptote. Okay, so no horizontal asymptote. X and y intercepts are found easily because of the format of this function. So the numerator is equal to 0 at negative 1 over 2 and 3. There is a y-intercept at 3 and vertical asymptote. Why did I put no vertical asymptote here? No idea. Since there is a restricted value at 1 over 2, so you do have one vertical asymptote. So there is 1 at x is equal to 1 over 2. So we have no horizontal asymptote. We have one slant asymptote and we have vertical asymptote. So let's put this together with x and y intercepts and the fact that we have two asymptotes here. Let's try to create the graph of this function. Okay, so the green curve that passes through a value of 3 on x-axis right here, that passes through negative 1 over 2 and positive 3, behaves accordingly to two asymptotes. There's a slant asymptote, so this is the end behavior of the function. So the green curve will be approaching to this line, x minus 2, as x is approaching to infinity, or as values of x are decreasing, this curve will have a tendency of getting closer and closer to that slant line. The graph is disconnected at 1 over 2. This is not part of the domain, so this is where the vertical asymptote is. Okay, so there is discontinuity at half. Right here, what you see is the behavior of the function in terms of What is the sign when x is less than -1/2? What is the sign of the function of the interval between -1/2 and 0? Between 0 and 1/2? Between 1/2 and 3? And for the values of x that are greater than 3. So negative sign and positive sign simply means that the graph, the curve, should be located below x values or above x values. So we have almost everything. We have to identify intervals of positive and negative, and also we have to identify whether this is increasing or decreasing type of the function. So the function is negative on that interval on the left, right here. So this is the interval that, two actually disjoint intervals that define where the function is negative. Positive function is defined by these two intervals. So it does make sense because that coincides with x-axis here, where you show entire domain with restricted value at 1/2, and you see that parts of the graph are above and below. So we use test values. Remember from the previous video, how do I know whether I'm below or above x-axis? Use test value. Use any number on selected interval and plug it into the formula, and you'll see positive or negative. This is how you decide. The function is also increasing on entire domain. And how do we know that? Although we do this very intuitively at this stage, we can sort of observe that as you move from left to the right, you increase in value. Always you increase as you move from left to right. So this is how you know at this point that the function is increasing. There are specific ways of figuring this out, but that's covered in the calculus course, so future videos will discuss that. For now, just know it by using the following observation. Thank you for watching this video. I hope you really enjoyed it, as I enjoyed making this video for you. Post comments, questions, and hit the like button at the end of this video. Thank you. Bye for now.